Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on solubility as an equilibrium process. In our last lesson, we learned about the energy changes that take place during the solution process. We discussed each step in relation to its change in heat energy. And we discussed exothermic versus endothermic processes. We applied the concept of heat of solution to a solution of sodium hydroxide crystal. We determined that this is an exothermic process because heat is released. In today's lesson, we will describe the distinctions among unsaturated, saturated, and supersaturated solutions. We will discuss the preparation of an unsaturated and a saturated solution of sodium sulfate. We will also discuss the preparation of a supersaturated solution of sodium thiosulfate. This is going to be a very interesting lesson, students. If you are ready, then we will begin. We begin by pouring 50 milliliters of water into a beaker. We then add some crystal of sodium sulfate using a spatula and stir the mixture until it dissolves. At this point, the solution is unsaturated. This means that it is able to dissolve more solute, or sodium sulfate, if it is added. When ionic solids dissolve, they disperse throughout the solvent. Sometimes ions collide with the undissolved solute. When this happens, they crystallize. If the rate of dissolution is greater than the rate of crystallization, the concentration of ions within the solution continues to rise. Eventually, the dissolution rate and the crystallization rate become equal. When this happens, both processes continue. However, the concentration of ions in the solution does not increase. The system is said to have reached equilibrium, which means that the undissolved solute is in equilibrium with the dissolved solute. Let us return to our experiment. If we keep adding the sodium sulfate solute into the water solvent, it will eventually reach a state of dynamic equilibrium. Any excess solute that does not dissolve in the solvent is in equilibrium with the solvent. At this point, the solution is referred to as being saturated. It contains the maximum amount of dissolved solute at a given temperature in the presence of undissolved solute. Let us look at an example. Image A shows a colored solid solute added to a glass of water. In the next image, image B, the solution begins to turn a greenish color. This is because the solute is beginning to dissolve. In image C, the solute continues to dissolve, which suggests that the solution is still unsaturated. By image D, the solute has stopped dissolving. It has reached dynamic equilibrium with the solution, which is now saturated. Students, we have now discussed unsaturated and saturated solutions. To review, please write the definition of each term on a piece of paper.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. I am sure you had no trouble with this activity. An unsaturated solution is a solution that can dissolve more solute at a given temperature. A saturated solution is a solution in which the dissolved and undissolved solutes are in dynamic equilibrium. If those are the definitions you wrote down, then great work. If they are not, please alter your definitions so that you have the proper ones in your notes. Let us discuss another experiment that will help us to understand supersaturated solutions. We begin by preparing a saturated solution of sodium thiosulfate in a beaker containing 50 milliliters of water. Then we heat the solution so that the extra solute dissolves. The solution is now supersaturated. Supersaturated solutions contain a larger amount of the solute than saturated solutions. Honey is a great example of a supersaturated solution. If honey is added to water and then heated, it will dissolve. However, if it is left to cool, the glucose in the honey will crystallize. We can continue with our experiment by filtering the solution and then dividing it into two parts in two different beakers. Let each beaker cool undisturbed. After they have both cooled, one of them is stirred. Stirring the solution will cause the excess solute to settle. Students, please look at these images. The first image shows a hot, supersaturated solution. The second image shows the solution once it has been left undisturbed to cool down. The third image shows a cold, supersaturated solution after seeding. What is seeding? Supersaturated solutions are not very stable. Therefore, if a seed of crystal solute is added to it, it will often cause the extra solute to suddenly crystallize. Students, let us do an activity. Please explain step by step how to attain a crystallized supersaturated solution. You may draw pictures if it helps you to explain the process.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Let us go through the steps to attain a crystallized, supersaturated solution. First, an amount of solute is added to a solvent. More solute would be added and dissolved in the solvent until the solution moved from being unsaturated to saturated. Then, the saturated solution is heated so that more solute can be dissolved. The solution is then left to cool undisturbed. Once the solution is cool, a seed crystal of solute can be added, which will cause the solution to crystallize. Today, we learned about unsaturated, saturated, and supersaturated solutions. We also learned about solutions in dynamic equilibrium and solutions that crystallize after being seeded. This brings us to the end of our lesson. Until next time, thank you, teacher. Thank you, students.